it's just asking you to plug in to this equation. Change in G equals change in H minus T change in S. So you just take the numbers they've already given you, plug everything in. The only tricky part is that entropy is measured in joules and not kilojoules, so you have to divide by 1,000 so you'll get the right answer in joules for change in G. You're going to be tempted for this problem to use change in G equals negative RT ln K, but you have to remember that rule that at equilibrium, change in G should be 0 because the reaction has already reached its point. So you're going to put everything back into the equation, but just have G be 0, so that way you isolate the temperature and work out to be 950 Kelvin. Alright, so for this guy, this is pretty simple. You're just going to do some stoic. You have to remember that this change in H is for every 2 moles NF3, since that's what the actual equation says. So just as long as you have that in the bottom, you just multiply it by the amount of moles, so they cancel out, and you get negative 33.8 kilojoules. You're going to have to do a Lewis diagram for this one. You'll realize that there's only 3 connections to the F, so that's 3 bonds, but there's 2 molecules formed, so you're going to have 6 bonds overall. For the last problem, it's your bond energies. It's your weird funky thing where it reverses the products and the reactants. So you're going to actually have to get the energy of the bonds broken minus the energy of the bonds formed. So you're going to take all those numbers from that thing you had, plug it in, do some algebra. Remember that 6 bonds of an NF3 need to be put there from letter D. And then doing all the algebra out will come out to 141 kilojoules.